Okay, now that we have completed quarter 2, we are going to review what we have learned. Here's a question. We're going to find that angle X. We need to know that the sum of all the angles of a triangle is 180 degrees. Knowing that this first angle is 50, we're going to take 50 minus 180. That leaves us with 130. Now we're going to take 130 and subtract from 60. 60 minus 130 is 70. So the answer to that empty space would be 70. But that doesn't give us the measure of angle X. We do know that a straight line, which would be this line here, is 180 degrees. So if I take 70 and subtract 180 degrees, I get 110. So that means the measure of angle X is 110 degrees. Great job. Given that the midpoint of AC is E and B, this is the midpoint, so that means these two sides are equal, and BD is congruent to DE, that means this is congruent to this, which of these cannot be proven? Well, in this case, we know that this triangle here, BEC, is congruent to triangle DEA. How do we know that? The triangle congruency of side, angle, side. I know a side, this side and this side. I know an angle, this angle and this angle. And I know a side, this side and to this side. So that means this triangle is congruent to this triangle. But that also means triangle BEA is congruent to triangle DEC. How do we know that? Side, angle, this angle here, and side. Side, angle, side of these two triangles are congruent. So what do we not know? We do not know if CAB is congruent to CAD. Why do we not know these are congruent? Well, we're missing some information. We're not sure, we don't have enough information to even make that we can't prove it. We only know that AC is congruent to AC. I don't know if these sides are equal to these sides. So triangle CAD, I'm not sure if it is congruent to triangle CAB. What is the correct order for this proof? So that means it implies that the proof is already out of order. So let's figure it out. C is the midpoint of BD. Angle BCA is congruent to angle DCE. That's not marked, so I'm going to mark it. And triangle ACB is congruent to triangle ECD. And triangle C is the midpoint of EA. Well, you always start with the given. So certain things have to be done. So I have to know that these things are given. Why? If I don't know that number 1 and number 4, I can't say anything about triangles. I can't say anything about angles. I know because I'm looking at the picture and these tick marks were there before I put my mark. That means it's given. Also, I need to know that BCA and DCE, which are vertical angles, they have to be congruent. Vertical angles have to be congruent. So if you notice here, I'm keeping a running total. I'm not sure if 1's first or 4's first, but I know for a fact that 2 is second. And then finally, it's number 3. So if I was to guess, I could say, and I'm just going to put that here, I'm not sure if 1 is first or 4 is first, but I know for a fact that after 4 will be 1, or after 1 will be 4. Number 2 has to be second because we have to talk about the vertical angle in order to prove side angle side. And then finally, we are going to state that the triangles are congruent. If I was to extend that and say, is angle E congruent to angle A, I could say yes, and that would be my number 5. How is that true? By CPCTC. Corresponding parts of congruent triangles are congruent. Now that would have to be the very last thing I say. Great job. Given that line L is parallel to line M, so we know that these two lines are parallel. That makes this the transversal. Which statement is incorrect? Well, let's find out. Angle 1 is congruent to angle 6. That's true because alternating exterior angles are congruent. Angle 5 is congruent to angle 4. Well, that's true because alternating interior angles are congruent. Angle 1 is congruent to angle 8. That's true because corresponding angles are congruent. Angle 6 is congruent to angle 5. No, these are supplementary angles. They're not congruent. So that means that is the one that is incorrect. I'm grateful that I don't have to prove anything, even though it says that here. The question is really asking, with this proof, which statement is incorrect? Great job. Again, given that line L is parallel to line M, we are going to find out that angle 2 is 2x minus 45, and we already know that angle 4 is x plus 30. The question is, what is the measure of angle 7? Well, 7 and 4 have a relationship. Angle 7 is congruent to angle 4. How do I know this? Corresponding angles are congruent. So if I find angle 4, I will know angle 7. But angle 2 and angle 4 have a relationship too. Angle 2 is congruent to angle 4. How do I know this? Vertical angles are congruent. So I can set these two equal to one another. So 2x minus 45 is equal to x plus 30. Now I just need to solve for x. Is 75 my answer? No, 75 is what x is. The question is asking me, what is the measure of angle 7? So now I'm going to take that 75 and add it to 30. Why am I doing that? Because that is the equation for 4. And 4, as you recall, we said here is congruent to angle 7. So 75 plus 30 is 105. So the measure of angle 7 is 105 degrees. Which one is a, somebody misspelled something. It's supposed to be a rigid transformation, not a ridge transformation. Rigid meaning stiff or tough or permanent or preserving size and angle. So that means there are 3 rigid transformations we study. Translation, rotation, and reflection. These are rigid transformations. Now, we did study a transformation that's not rigid. That is dilation. A dilation is not rigid because I'm going to change the lengths of sides. So, all we're looking for is the purple and not the blue. Which image is a rigid transformation? That would be this image here. And why is that image the rigid transformation? It preserved the length of sides. This was 3, this is 3. This was 2. This side was 3, this side was 3. This side's 2, this side's 2. Here's your hypotenuse, here's that hypotenuse. So A prime, B prime, C prime is the rigid transformation. With that being said, the A double prime, B double prime, C double prime is a dilation. But it's also a reflection of A prime, B prime, and C prime. So don't let it fool you because there are 2 transformations here. Just because it's a flip as well as a dilation, it's not a rigid transformation because there was a dilation. We are given this line. L is parallel to M. And angle 7 is 100 degrees. We need to find the measure of angle 3. Well, 7 and 3 don't have any direct relationship, but I know that angle 7 and angle 4 does. What is it? They are corresponding angles. Angle 7 is congruent to angle 4 because they are corresponding. Corresponding angles are congruent. So if angle 7 is 100 degrees, angle 4 is 100 degrees. And because line L is a line and it's parallel, we know that if I take angle 4 plus angle 3, I should get 180 degrees. Now it's just a matter of substituting in to find my angle. I like algebra. Angle 3 is 80 degrees. Great job, everyone. Which statement is not true if the triangle ABC is congruent to triangle CDA? So we're trying to choose a statement that is not true. So let's find out. I like to mark my picture. Segment A is congruent to segment CD. AB is congruent to CD? That is true. Why? By CPCTC. Corresponding parts of congruent triangles are congruent. And then it says AC is congruent to AC. Is that true? Yep, because of reflexive property. Then we have angle CAD is congruent to angle ACB. Why is that? Alternating interior angles are congruent. Or by CPCTC. Finally, The correct answer is